We all kind of have this neat little timeline in our heads for how technology was invented. The wheel, then the printing press, then the steam engine. It all seems to follow a nice, clean path. But what if I told you that one of the most important inventions for our modern world, the battery, is completely out of place on that timeline? What if the real story is thousands of years older and was hiding in plain sight all along? So let me ask you a simple question. Who invented the first battery? I bet a name immediately popped into your head, right? The one we all learned in science class. It feels like a settled fact. Well, today we're going to look at an ancient text that might just blow that entire history right out of the water. On one side, you've got Alessandro Volta, 1799. He's the guy in all the textbooks, the official father of the battery. But then, look at the other side. We have Sage Agastya, an ancient Indian writer from around 2000 BCE. The claim here is absolutely wild, that he laid out the blueprint for a working battery almost 4,000 years before Volta was even born. Now, where does this crazy idea come from? It all centers on a text called the Agastya Samhita. For centuries, most people thought it was just a collection of spiritual verses and poems. But when you look closer, some of the language seems, well, it seems way too technical, almost like an instruction manual that shouldn't exist for its time. The whole argument really boils down to how you interpret these verses. Proponents say that hidden in the poetic language are, and this is their analysis, explicit step-by-step instructions for constructing what a modern engineer would immediately recognize as a functioning galvanic cell. So the idea is, this isn't just poetry, it's a schematic.
So, what are these instructions? This is the cool part. Let's actually break down this ancient recipe piece by piece and see how it lines up with, modern chemistry. We're going to translate ancient Sanskrit into a science project.
The instructions are shockingly clear. First, you take an earthen pot, which acts as a great insulator. Then you put in a copper plate, which would be your positive electrode, your cathode. Then it calls for something called shikgriva, which literally translates to the neck of a peacock. Well, guess what has that beautiful iridescent blue color? Copper sulfate, the perfect electrolyte. To keep things from shorting out, you add wet sawdust as a separator, and finally, a zinc sheet serves as the negative electrode, the anode. You guys, that's a battery. That's the whole recipe. So here it is, all laid out. The ancient Sanskrit terms on the left, and their modern scientific functions on the right. Tamrapatram, the copper plate, is the cathode. Dastaloshto, the zinc sheet, is the anode. Shikriveva, the copper sulfate, is the electrolyte, and the wet sawdust is the separator. It's a one-to-one match. The names are ancient, but the science is identical to what we know today. But hold on, because the story doesn't stop with just one little clay pot battery. Oh no, the Agastya Samhita goes so much further. It describes how to create a lot of power, and it even tells us why they needed it. This is where it gets really wild. A chain of 100 jars is said to give a very effective force. Think about that. It's not just describing how to build a battery, it's describing how to build a battery pack, how to link them together to get more power. What he's talking about is a series circuit. 100 of them. Can you just picture that? Not one little pot, but a massive array of 100 jars, all connected, all humming with energy. The text is describing an industrial-scale power source. We're talking about generating some serious energy. And that effective force it mentions, if you do the math, connecting 100 of these cells in a chain would generate over 113 volts. To put that in perspective, your car battery is only 12 volts. So this ancient setup could theoretically produce nearly 10 times that. That's a lot of power. So you have to ask the question, right? Why? Why on earth would an ancient civilization need to build such a high-voltage power system? What could they possibly be using it for? Well, believe it or not, the text gives us a jaw-dropping answer. And that answer involves a process called electrolysis. It's pretty simple, really. It's when you run a strong electrical current through water to split the H2O molecule apart into its basic components, hydrogen gas and oxygen gas. The thing is, it takes a good amount of voltage to do it. The kind of voltage you get from 100 jars chained together. And that is precisely what the Agastya Samhita seems to describe. It says you can use this electrical force to split water into something called pranavayu, which proponents interpret as oxygen, and udanavayu, which they say is hydrogen. This ancient text appears to be a recipe for a hydrogen generator. And it even spells out the end game. The goal was to collect this udanavayu, or hydrogen gas. The method was to trap it in an airtight cloth. And the purpose? Get this, the text says its purpose was to make it fly in the air. I mean, come on. That sounds an awful lot like they were describing how to fill a balloon with a lighter-than-air gas. Okay, I know what you're probably thinking, because I was thinking it too. This all sounds a little too good to be true, right? It's an amazing story, but does the recipe actually work? Could you really build a battery from these 4,000-year-old instructions? Well, modern science decided to put it to the test. A group of researchers did exactly that. They took the text at its word. They got the clay pot, the copper, the zinc, the copper sulfate, all of it. And they built a replica, following those ancient instructions right down to the last detail. The results were frankly incredible. The replica Agastya cell produced 1.138 volts. Let that sink in. A modern AA battery, the kind you have in your remote right now, is about 1.5 volts. This ancient, simple design got remarkably close. This wasn't just some little trickle of energy, it was real, measurable electrical power. And it wasn't just voltage, which is like electrical pressure. It also produced a current of 23 milliamps. That's the actual flow of electricity. It proved the cell could do real work. The bottom line? It worked. The 4,000-year-old recipe actually worked. So what does this do to our tidy little timeline of history? It kind of shatters it. This new timeline suggests that a shockingly advanced understanding of batteries, circuits, and even electrolysis might have existed almost 4,000 years before Volta. It suggests that a massive piece of our own tech history wasn't invented, it was just rediscovered. So the big takeaway here is pretty mind-bending. When you combine this interpretation of the ancient text with a successful modern-day replica that actually works, you get a really powerful case that the story of electricity is way, way older and more mysterious than we ever thought possible. And that really just leaves you with one final haunting question. If a complete blueprint for a battery and a hydrogen generator could be sitting in a text, misunderstood for thousands of years, what else is out there? What other forgotten technologies are just waiting in old scrolls and dusty books for us to find them?